Hey everybody, it's Ben here, and today I want to show you how I made a 3D model of a Nissan Leaf electric motor to use in some CAD software for pre-visualizing a project I'm working on. Now to start with, I did not use a 3D scanner. This happens to be a Sense handheld 3D scanner. It's not what I used. When I decided I wanted to do this, I just asked friends online, hey, does anybody have a 3D scanner I can borrow? And sure enough, one guy did, so I went and I got this from him. Unfortunately, it looks like this is the older version, and the software is designed to run on a certain Windows operating system. I happen to be on a Mac. But what I did already have is a pretty nice DSLR camera, and so another friend suggested to me that I should use something called Photogrammetry. And what Photogrammetry, and I'm overpronouncing that because otherwise I will not say it right at all. It's basically just taking a whole bunch of photos, sticking them together, and creating 3D objects from it. And what's cool is, hey, I already have a camera. After that, you just need software. So let's take a look here. I started off just by taking a whole bunch of photos. So this was with my Canon Rebel DSLR, and I took the Nissan Leaf motor and I just set it out in my driveway on top of a bar stool. I figured that way I had plenty of room to walk around it. And the background changes. You know, sometimes it's the driveway, sometimes it's grass and dandelions in the background. But basically, I walked all the way around with my camera. Just move over a little bit, click a photo, move over, click a little photo. And I got a couple different angles. I got sort of straight on. I got some higher angle photos. I got some, this for example is kind of straight on from the bar stool, so I can kind of see under the motor a little bit. Now, of course, the bottom's not going to be very good because it's just sitting right on that bar stool. But I did get some high angles, some low angles. One thing I did learn from doing this is that you probably want to make sure that you're using a fixed lens. So I was using a DSLR with a kit lens, a zoom lens, and there's a couple times I zoomed in or out a little bit just to frame up better. And when I brought this into the software, it said, you might not want to do that. Using different focal lengths, it can actually mess things up. So if you're just using I don't know, your smartphone or something, that's fine. But if you're using a DSLR, you probably want to use a fixed lens, a prime lens. So let's take a look at the actual software that I used to put this all together. I did this in a program called MetashapePro. Here's that software. And what this is, apparently it's pretty high-end software, but they have a 30-day free trial for you. So many things I get into doing, I just do once, or it's just an experiment, and I don't want to shell out big money. So trials or open source software, things like that are great. So the first thing I did was in MetashapePro, went to Workflow, Add Photos, and I brought all the photos in. There was, I think it was 190 photos altogether. If we look down in the corner here, where I'm not, but over here in the corner, you can see these are the photos. And actually, if I kind of scroll through them, you get to see kind of a neat little animation of me walking around the motor. But if we come back out to sort of our main area here, after doing that, I went to Workflow, Align Photos. And this is the point where basically what the software does is it looks at all these photos and it finds any points that are in common from one photo to another, and it says, aha, that's where the overlap is. I'm going to remember that and mark it down. And it does it for all the photos. And by the time you're done, there's, well, the next step is what they actually call a point cloud. So it just makes all these points in 3D space. And that's actually what you see on the screen right now. Now, keep in mind also that all this tends to be pretty computer processing intensive, so it takes a while. So the aligning photos, making a point cloud, renders, they all take a lot of time. This whole process I'm going to show you here was probably 2 hours total processing time. So some of that I do something and go take a break or have dinner or whatever. But just keep in mind, it does take a bit of time. So after after the photos are aligned, the next step is to build a dense cloud. So the first thing we have here is this point cloud. So it is literally just points. It's like puntillism. There's no depth or anything, just points in space. But if you kind of look back and squint, you can sort of see the shape of the electric motor there and the top of the bar stool. And as a negative, there's a whole lot of just random points in space in the background, which is not what I was looking for. But the next step then was to build a dense cloud. So workflow, build a dense cloud, wait some time because this takes a while to process. I already did that, so we can just go straight to the dense cloud. So now, if we go back a little bit, boy, that really looks nice. I mean, that's a nice image of the electric motor. Good color, good shape, pretty darn good, except for the bottom, because I didn't take bottom photos of the motor because, you know, of course, the bar stool was in the way. But I figure that's the least important part of all of this here. But if I zoom in, it's not solid. It's still just points, although there's a lot of them. And most of these points are interpolated. They are made up by the computer, just kind of averaging together all those points that were generated from the photographs. But man, we just go back a little bit and sure does look pretty darn good though. But it's still points. So the next step then is to build a mesh. And what a mesh is it's like a net, or like if you can imagine chicken wire. It's basically not a solid thing. It's sort of a shape made up of typically various polygons, triangles, quadrilaterals, rectangles, things like that. So let's go now to our mesh. And in this case, I have it viewed as a model solid, but if we look at model shaded, this is kind of neat. What it is it's the 3D shape now with essentially an image superimposed on it, so that we have the color and the texture look from the electric motor. But if we go back to just the solid and zoom in, you can see all these little shapes I was talking about, and they're irregular. We've got you know, triangles and rectangles, all sorts of different sizes and shapes. But overall, you know, that's a pretty good 3D rendering of this shape. It's not perfect. You can see a lot of things are kind of rounded off a bit, especially like looking into bolt holes, for example. But some of this I could always clean up a little bit more later. The big one too, of course, is the top of the bar stool is just one hunk of this is all, you know, computer just thinks this is just one big solid mass. And one more step we can do after this is a tiled model textured. So if we look at this, this gets really interesting. First of all, you see all this weird junk on the screen. It's like we're in a space movie in an asteroid storm or something. And what that was all these points in the background. And I think what happened was both my driveway and the grass in the background are sort of weird natural shapes. They're organic. And I think it was accidentally, incorrectly putting together different points, the green and the gray, and matching them up, even though they didn't match up. So what I had to do was, in this mode here, I was able to just select points and delete them. But I still have those as a, I didn't re-render this yet, just so you could see what it looks like. And this is one of the problems. You know, you can have a whole bunch of junk in your way if you're not careful, but it was relatively straightforward to clean this up just by deleting all that from the other mode. So now back here, we've got a pretty good looking 3D image. And from here, I was able to go to File, Export, Export Model. And in there, I exported a STL format model. I already did that. So now let's go take a look at the model. Now you have to remember that an STL file, it's literally just a shape. So if I just take a look at this in preview here, it's matte white. There's no scale information, there's no color information, there's no images overlaid on it. It's literally just a shape. But if I zoom in on it, we can see that there's some pretty good quality there. All these little facets. This thing is made out of quite a few polygons. Here's the drive shaft. The underside of the drive shaft didn't come out real clean because I didn't have a lot of really good low angle views of that. But the overall shape really looks pretty darn good. So at this point, essentially a person could just 3D print this and it would look pretty darn good. The only thing is you'd have to tell it how big you want it to be, which is fine because usually for 3D modeling, you know, you want something that's a scale model. So you just say, oh, I want it to be 4 inches high or whatever it is. Again, still on the bottom, we don't have any information there, and that would have to be corrected in another program if we wanted to do that. So now what I'm going to do is go over to a program called Fusion360. And Fusion360 is a pretty cool program. It's a CAD program that is actually up here, Autodesk Fusion 360, personal, not for commercial use. So you can download it and use it for free for learning on, for personal projects, things like this. And there's a lot of great tutorials. So, you know, anybody can learn it. It just takes a little bit of time. So let's take a look here. What I've got, oops, and I somehow made my sidebar disappear. Gosh darn it, how did I do that? There we go. I've used Fusion 360 a little bit. I've gone through some tutorials. I'm not an expert at using it. I'm a beginner. It's always good to suck at something new because that's when you learn a lot about something. So what I did is I brought in that STL file, and if we look here, if I go to the right one, this is what that STL file looks like in the software. We're looking at a view here. We kind of see through it, but if we zoom in, again, we can see all those little triangles that compose this shape. There's a lot of detail there. And in this case, that's actually a problem because what I need to do is convert this into a solid object so I can use it in CAD here. And if I try to convert it, if I just select it, right click it, hit convert to BREP, over here, it's going to give me an error. Basically, it says there's too many facets. This object is made up of too many polygons. Nope, it's not going to convert it over. Now, fortunately, there's a way to make it out of fewer polygons. So if, again, if I just have it selected, and in the mesh menu, I go to modify, there's this reduce. And if I select that, it lets me make fewer polygons. Now the reduce type, there's adaptive and there's uniform. Adaptive means that it'll make different size triangles. Uniform, they're all going to be the same size triangle. So I'm going to go with adaptive. And reduce target, you can go by density or face count. Now density is, you can think of it as like how many triangles per square inch, for example. So if I'm at, let's just type in, 0.5, there's going to be half as many polygons making up the same size area. So if we wanted to reduce it a lot, we could go down to, 0.25, 0.1, whatever. This doesn't tell me a lot of information though. If I go to reduce target face count, it actually tells me how many faces there's in here right now. At this point, there's over 90,000, and that's still a lot. I've heard that this software wants less than 10,000. So I could go back to density and set it to you know, 0.1, it'd be a tenth as big, that would get me there. Or face count, I could literally just type in a number and apply it. Now, what it's probably going to do is still give me a warning saying, hey, you still might not want to do that. And my computer is running a little slow because I've got all these programs open at the same time here. So what I did is I'm just going to show you the mesh body that I already made. So this one here now, you can see how it's made out of fewer polygons. There's still, you know, different sizes and shapes, but there's a whole lot fewer of them. Then what I'm going to do is I'm going to take that, and now I can convert it. Mesh to BP rep. Operation new body, just it's going to be a new thing. And I get not an error message, but like a warning, says it's not recommended. You still want to do it, and I just say yes. And now the other thing is, after converting it over, what I needed to do was it became a surface body. There's different types of bodies in Fusion 360. So surface is like if you were like making a box, like packaging, that kind of a thing. So in there, I needed to use modify stitch to join all the surfaces together and create a new body from it, which made a solid object. So when I was done with that, what I had was, let's go to our home view. This. And this looks a little weird. This is now a solid object, but I had to reduce the polygon count quite a bit to make it work in the software here. And frankly, it lost a lot of resolution. After I converted it, I did also, you know, I had closed up the bottom, and then I just kind of cut the barstool part right off. So kind of right down here, I just cut it in a straight line. But it's sort of low resolution. It's not quite ideal, and it's got this weird faceted look. It looks like it's, I don't know, like a gemstone or something odd like that. The other thing is, remember I said that the STL file wouldn't have any information about scale. So let's see if we can zoom out a little bit here. If I have our original image right here, and then the one I'm finished with, you can see there's quite a bit of difference. When I brought in that original one in this workspace, it was tiny. It was like, the whole thing was like smaller than an inch. And I went, well, that's not right. But there was no scale information, right? So basically what I did was I just went back to the motor, just with my tape measure, and just like across here, for example, I could measure what that distance was, and then I could measure that same distance right here. There's inspect, measure. It's just kind of like a little virtual tape measure. You click a point, you click another point, and then it will tell you, for example, what the distance is between the two. So right here, 7.408 inches, and I just compared that with the original actual physical electric motor, and then I just scaled the model until it was the same size as the motor. So now that I've got this motor, even though it's kind of this kind of low resolution, crystallized kind of a thing, most of what I want to do with this is for positioning. So the fact that it's relatively low resolution isn't so much of an issue. I will say the one thing that I kind of spent the most time on right here in converting this was, frankly, it was just getting the 3D model level, oriented correctly. This motor is kind of a weird organic shape, except for the fact that on the top there is pretty flat. across here and across here, which is actually where the inverter mounts. That's pretty flat. That's pretty coplanar. And just getting that to be up and flat and just everything lined up correctly in 3D space, that took a little bit of work. The other thing then too is once I did that, I made sure to center it. Now, there's something called the origin. And what the origin is it's sort of the center of the 3D universe. You see a little bit of a red, a blue, and a green line in here. So that's XYZ 0, 0, 0. And what I did in this case is I want this model to line up right on that drive shaft. So I selected a point on the tip of the drive shaft, and then in this model, gotta close this other thing first. So there's a nice feature in here where you can move an object, but specifically to a certain point. So what you do is you select the object you want to move, use the point-to-point setting. You actually pick a point right on the object, and then you can move that point to another specified point. So you can perfectly line up one thing with another thing. So where I moved it to was the origin, and that way basically the tip of the drive shaft was right in the center of the universe, so everything is centered. And if you want to do things that rotate, for example, it's probably a good idea to have the main axis that is rotating going right through that origin point. So we've got a pretty good 3D model here now, and this was just the model. So what I'm going to do is bring it in to kind of my main project space, which I've already got open. So we'll go to this here. And right now I'm actually working on a project converting an old International Harvester tractor to electric. Those tractors are red, so that the tractor parts, I just made them red right here in the software. I already have a plate that lines up with the Nissan Leaf electric motor. That was a CAD file that I got from a friend and I imported. I 3D modeled a hub that the flywheel of the tractor is going to mount to. On the side, I have these rails. These connect from the bell housing back to the front of the tractor. Those are real-world physical pieces. Now, I just kind of mocked them up. I hand drew these. They're this part here is pretty close. It's not perfect. The rails are pretty much dead on, though. And then the other thing, I've been playing around with an idea of some way or another of getting power out of the Nissan Leaf drive shaft for running a hydraulic pump. And maybe I just do that by having a chain or a belt to pull off some power, and then I would have the pump mounted kind of down in the corner here. Still trying to figure that out. I think a chain would be a little bit too loud, but at least I could use a master link to put a chain on there, whereas a belt, I have no idea how I would get that on. I'd have to make the motor slide back to slip a belt on or something. But let's take a look here. Let's go to our default view, and remember we just talked about the origin. So if we show that, that's right here in the middle. The origin is where those three planes come together, and if we make some of these other things just kind of disappear for a moment, it's probably a little easier to see. It's right there in the center. So what I did was when I brought in my model of the electric motor, I already had it centered on that. And then all I did was I just moved it straight back away a little bit, because remember that was the tip of the drive shaft that was centered on there. I want a little bit of space here. And let's turn back on those other plates so we can kind of see how everything interconnects. So right now, this is a fairly good 3D mock-up of what I'm trying to do. Since I've got the motor model here, I mean, it's weird and faceted and everything, but it's essentially the right size and shape. So I can see how this adapter plate here, which would bolt up here and also bolt to the motor. I can see how that lines up. We'll actually turn this one off for the moment and get a little better view in here so we can see how that lines up. Let's take a look at a few things. This is kind of interesting. If we're just looking at the right hand side here, and I've got this set up where if I go to front, top, or right side, it goes two-dimensional, just a very flat view. On the casting of the electric motor, there's kind of an overhang here. So even if we wanted to have the face of the electric motor bolted right up to the tractor here, we can't. And it's because there's this overhang. So this is one of those things where being able to take a look at it in 3D space kind of makes a lot more sense. So that was also one reason why I thought possibly if I can do it, if I can fit a sprocket or a belt pulley in here, might be a good spot for it because the electric motor can't be all the way forward anyways. Now the inverter is going to mount on top of here. Seeing as how I was pretty successful with this 3D scan overall, I'll probably try another one now with the inverter mounted on there so I have both components together. Here's another thing to take a look at. I remember when I actually did lift the motor and I put it right into the on a box in front of the tractor. One thing I remembered is that the cooling ports on the Leaf motor were pretty close to the side rail. And if I zoom in here, those really look like they're pretty much almost exactly where they were back on that photo. And I was a little concerned that it was close there, but it's not hitting. And I mean, I could always put right angle connectors on the radiator hose if I want. But it's pretty cool just to be able to kind of see all our clearances. Again, the bottom's not quite perfect, but the bottom detail isn't a big deal in this case. But just pretty cool to be able to check all the clearances on here. Another part I may want to end up 3D modeling is there's a part under the tractor, sort of a yoke that comes from here up to the front axle. And that's a little bit of a concern for clearance on the motor. And then also if I try to add anything else down here. But I'm pretty excited about this. It's a low-res model. I'm sure there's probably better ways of doing this. I'm just not very experienced with Fusion360. But it looks cool to be able to just have it in there, see that things fit. And what I'd really like to be able to do with this model is if other people are doing projects where you've got, let's say you just want to take a Nissan Leaf motor, put it into a car to do an electric conversion, it sure would be nice just to see if the motor is going to fit and maybe spin it in 3D space instead of having to physically move the motor. I mean, this motor is heavy. It really weighs more than it looks like it should. And so being able to just manipulate it on the computer is pretty cool. It's really neat to be able to do. I know playing around with all this CAD stuff is a little bit of a side quest to working on converting this tractor to electric. But again, right now at this moment, I'm a little bit limited. The whole COVID-19 situation means the machine shop where I'd be working on this is shut down. Mail order parts are slow, some things like that. So I thought, why not use this time to learn a little bit about 3D and how I can use it practically in projects I'm already working on. So if you have some ideas for how to make this model a little better, a little more high resolution, say so in the comments. Please, keep it positive. This is literally the first time I've ever done this. So, don't rag on me for, it being a little low polygon count and boxy and everything. Now, of course, the other thing is, once I converted it to a solid model, there is absolutely nothing keeping me from using any of the tools in the software to recreate the drive shaft and make that perfectly straight and the right size and the right number of splines on there. I could sort of virtually mill the top here, make it perfectly smooth. There's all sorts of great tools in here where you can drill a hole and add tapped threads. So I could certainly keep working on this model, not as a 3D scan, but as a traditional CAD object, and clean it up, put the bolt holes right where I need them to be and everything. But for now, for just checking position and everything, this looks pretty good. It's working out. So I hope you like this video. Again, a little bit different than the videos I'm usually doing. But yeah, I hope you like this. Please comment, subscribe, check out the blog over at 300mpg.org, and let's collaborate. If people could make use of a Nissan Leaf 3D model, let's do what we can to do this kind of thing and, make it good. Put those holes right where they are and share it. So we'll work on getting that out there for you. So until next time, stay charged up. Oh God, how do I stop the recording?